will be given by Kalvis Salmins, talking about preliminary results of new event timer with the IECS technologies.
Good afternoon, everybody. Before I start my talk, I want to make a small introduction. This first, I would like to emphasize, this is a research project. We have had such project before, which long time ago resulted in our own event timer, RTS 2006, which was reported in Canberra workshop in 2006. And this is kind of a similar development together with the Institute of Astronomy and Institute of Electronics and Computer Science, which is IECS. Second, this work is based on two different developments. First is one project from Institute of Electronics. They researched how to improve the timer stability. And second project was also presented in last Canberra workshop when we demonstrated the improvement of our old RTS system by improving these amplitude measurements and how to compensate time walk without constant fraction discriminators, and basically software-only solution. And this project is kind of, we try to put together these two different results from these two different projects and to make something new, which may be interesting for let's say laser engine community and other users, because they are also involved some group of physics in it. So here is a brief description of this new project. So the key differences we are based on this S08T10 is just a code name. Yeah? So don't search for such an event timer on the website. It was an Institute of Electronics project, and they chose such a name for their research. And also, it's about the idea was because it's our previous time walk compensation was based on the amplitude to time converter, and it does just put some. It's first you need the dedicated software for it, and second, it limits, let's say, the measurement rate, because you have to also this amplitude measurement comes into the timer as a time measurement. You have to make distinction between two types of measurements. And the idea is to make these things parallel. So we get the time tags for the events, and at the same time we got information about the signal. In this case about, let's call it signal amplitude. Because sometimes it's not only for time walk, sometimes it's just interesting to know what's coming in. And this type of approach will allow to see not only the timing information, but also what the signal strength is. So here are some basic what we are expected to get at the end. So first, the one principal change, now it will use analog inputs. There are no more logics, we're just getting, so we're kind of eliminating the middleman. We are getting straight from the PMT preamplifier or some other detector, we get analog signal. We can set what we want, where to look, and get not only the timing information at user-defined threshold, but also what will see the signal strength. And there's some other minor, I would say, incremental improvements over the previous timer. So here is some, let's say, test results from the lab. With a comparison with this previous development and this new, which is currently under construction. We have already the first example, only this ET40. Unfortunately, to the delays in the supply chains, it was expected that we had already all of the participants of this project will already have this new device. Unfortunately, it's not the case, but this exists only in the lab. So here is a measurement ranges, what we expect from the stability. And here is a bit, we are also talking about reducing the dead time, but unfortunately it's tied also this pulse amplitude measurement. If we want to get better here, we will lose something here. It's again some kind of design decision how we will move forward. And also the pulse measurement range amplitude is either positive or negative. We can go from the 50 millivolts up to the 2 volts. There is a question what to do with if you have the classical NIM logics or TTL. The NIM will work as usual. Of course, the amplitude measurements in this case doesn't make much sense. TTL will also work despite the indicated range of measurement, but the amplitude measurement up to now it's decided will not be available. So here is our test setup. As I said, how we expected to test it in the laser ranging station. On the left you see our old event timer, here is ET40. But as I said, this timer still don't have the analog input, so we can use it only to learn this new software and also to try to combine it with our old existing so-called TS-ATIC technology. And a brief summary what we are about to do, because this is all what I present from this preliminary results now, is that our lab we will test with laser ranging station. We will test with a laser what we have. In primary detector channel we have the classical PMT. This TS-ATIC is actually the amplitude to time converter and old RTS timer. In the second we have the another detector which we are about to test. This is so-called hybrid photo detector. This is for our space debris tracking. It's quite interesting device. For some reasons, it's not mentioned in the SLR community yet, which goes through currently the CFD just to get the NIM signal and the ET40. And what I can say is the stability certainly is improved, especially if you compare it with our old timer, which needs to do scaling time to time. Here I tried, always I get the same precision, and it looks like it really works, let's say, in field conditions quite well. The aim is actually to get to such a level, so just turn the timer on, maybe do scaling once, and it should run with the same parameters as long as it's on. And the calibration performance, we tried also to calibrate, but it's not so easy for us as just to reconnect the cable, because it involves, as I said, this amplitude to time converter. Then we have to make dedicated software. Of course, the calibration precision is increased, as expected, no surprises here. But how well will work this amplitude measurement, this unfortunately we are not able to tell yet. This is an expected end of the project is the next spring. So I hope for the next workshop we can report more how this final results of this project. So that's all for this presentation. Thank you for the attention. And of course I have to acknowledge the funding which comes from European regional funds. Thank you.
Thank you, Kalvis.